Okay, sorry, little confusion there at the beginning. In this equation, we're looking at what happens as x goes to infinity now. So let's look at a table of values. All right. If we look at our first equation, x squared minus 9 over 2x plus 6, and we substitute in 100 and then 1,000 and 10,000, 100,000, and so forth, we get 48.5, 498.5, 4,998.5, and then on and on. And these numbers are just getting bigger and bigger and bigger. And this makes sense on the graph because notice as x gets bigger and bigger, y is just getting bigger and bigger and bigger too. Okay? We could just keep going, and x gets bigger, y gets bigger, x gets bigger, y gets bigger. This tells me I have no horizontal asymptote. The graph does not ever level off. It just keeps going up and up and up and up. That's one possible thing that can happen. Now, how do I know when the graph is just going to keep going up and up and up and up? I know that when the degree of the numerator, which is an x squared, has a degree of 2, is bigger than the degree of the denominator, which has a degree of 1, x to the first. X squared divided by x to the first is x. If something is x to the first, it's a line. So this graph just looks like a line. Now there is a hole in here somewhere. We found out that before, that if I were to substitute negative 3, in this case, if I were to substitute negative 3 in for x, I would get 0 over 0. There's a hole in this graph. But it's basically a line because it's an x squared divided by an x. Anytime if this had been an x cubed divided by an x, it would look like a parabola, but it would just continue to go up and up and up. It would curve, but it would curve up. There's no horizontal asymptote. It would not level off. So anytime the degree of the numerator is bigger than the degree of the denominator, has nothing to do with the coefficients, just the degree, the exponent, then there is no horizontal asymptote, and so there is no limit. In other words, as x gets closer to any particular, as x gets bigger and bigger, so x is not getting close to a number, as x is getting bigger and bigger and bigger, y is not getting close to any particular number, so there is no limit as x goes to infinity. Now when we look at the second example, okay, we see putting in 100 for x, 1,000, 10,000, 100,000, so forth. So we see 0.002, 0.0002. Now I wish this would show it with decimal places. It uses scientific notation, but 10 to the fourth, this would be 0.000249. This would be 0.0000249. In other words, as x is getting bigger, y is getting smaller. If we look at the graph, we can see, excuse me, we can see this happening. As x gets bigger and bigger, what's happening to y? So let's look at, let's grab there. If x is 100, y is 0.0024. If x is 500, y is 0.0005. If x is 1,000, y is 0.0002. If x is 10,000, basically rounds to 0. Not exactly 0, but it's getting really, really, really close. So what we're seeing here is, here's x getting, this must be turned on from a previous one. Hang on, let me turn these off. Oh, yeah, sorry, some points are still on from previous. Excuse me. So we see, as x is getting bigger and bigger and bigger, so here's x is 100.024, 1,000, 0.0002, 10,000, pretty much to 0. Let's see if we can find something that's not rounded exactly to 0. Okay, there's 0.0001. So I'm zoomed so far out it's hard to see, but what we have here on this graph is an asymptote, a horizontal asymptote. As x gets really, really big, y gets close to 0. Apologize for my voice. Sorry, I had a little bit of a coughing fit there. Now, how do we know that the limit is going to equal? That means that the limit equals 0. We're saying as x gets infinitely big, y gets closer and closer to 0. So there is a particular value that y is getting close to as x gets infinitely big, and that's 0. Now, how can we tell from the graph that that's going to happen? Or sorry, from the equation. If the degree of the denominator is bigger than the degree of the numerator. In other words, this is an x to the first, and there is no x value at all. It's just a constant in the numerator. If the numerator had been x and y had been an x squared, and the denominator had been an x squared. If the numerator had been an x squared and the denominator had been an x to the fourth or something. Whenever the denominator has a larger degree than the numerator, when x gets really, really big, the denominator will get bigger much faster than the numerator. And so the entire number for y will get smaller and smaller and closer to 0. Now, the last one is the only one that really involves just a slight calculation. When we look at this graph here, we see that there is a horizontal asymptote at 2. As x is getting bigger, and think about moving the x value farther and farther from the center of the graph in both directions. So as x is getting really, really big, let's look at what's happening to y. As x is getting bigger and bigger and bigger, y is getting obviously close to 2. Even when x is only 100, y is still really close to 2. When you get to 100,000 and a million and a billion, it just rounds off to 2. How can we tell that as x gets bigger and bigger, y is getting closer and closer to 2? We can see it from the graph. How can we tell it from the equation? Well, if you look at the equation, the degree of the numerator and the degree of the denominator are both 2. In other words, the exponents are the same. The exponents, the highest degree exponents, are the same. If they are the same, then we ignore the other terms and we just look at those two highest degree exponents and we say, well, 2x squared divided by x squared is about 2. Like 2 billion squared divided by a billion squared is about 2. If we were to put a big number in, that's what happens. So that's what tells us then that we're going to have a horizontal asymptote at 2. So to recap, if the numerator has a higher degree, a higher exponent than the denominator, then you know that there's not going to be a limit at all. As x gets infinitely big, y gets infinitely big. If the denominator has the higher degree, then there will be a limit and it will be 0. As x gets infinitely big, y gets close to 0. If the numerator and the denominator have the same degree, then you look at the coefficients of the highest degree terms. And whatever that reduces to, that's going to be your limit. So 2x squared divided by x squared is just 2. And that will be the horizontal asymptote. So when you're looking as x goes to infinity, all you're looking for is there a leveling off of the graph to a particular value of y, or is there not? In the first case, no leveling off. As x gets bigger, y gets bigger. The second two, yes, it levels off. The first time to 0, the second time, in this case, to 2. So all you're looking for is there a horizontal asymptote or is there not? As x goes to infinity doesn't tell you anything else about the graph except horizontal asymptotes. Vertical asymptotes come from having a particular undefined value of particularly undefined value, an undefined y value at a particular x value where y gets infinitely big. And that would be this case up here.